All right. Before we get too deep into this, how many people in this room are ready for beer? So you will be pleased to note that the only thing standing between you and beer is me. Wait, that didn't come out right. How many people in this room are kind of tired? I've just had my brain turned inside out several ways over, and so I'm going to come to a keynote and study something really sort of light and pleasant and not too complicated, like programming languages. That didn't come out right either, but we'll go with it. One of the things from having done many of these conferences over the years is that what I've found is the people who sit in those chairs frequently are asking the same question, right? What is the secret sauce? What is the magic pill? What is the new framework? What is the hot platform? What is the thing that I need to know so that I can go back to work and remain safely employed for the next 2 years? Right? Because that's what we really want. I mean, all of this, giving back to the community, all of this, trying to improve, follow our passions. What I really care about is not getting fired, right? Or getting outsourced. Or I guess if you're in one of those countries you traditionally outsource to, is it outsourced? Insourced? Sourced? I don't know. What is the next big thing in our industry? The answer is programming languages. Thank you for coming to my keynote. Enjoy your beer. Fastest keynote ever. But you're still not leaving. So fine, let's talk about this. There's a whole bunch of different things that are happening in the industry right now that are sort of putting a lot of impetus and emphasis around programming language, language research, language ideas, etc. What that means is, in many cases, obviously, we're going to be looking at using a number of languages coming down the pipe. We already, of course, use a fair number of programming languages in our day-to-day job as it stands. But what I believe is that we're actually going to start to see an explosion, a renaissance of programming languages, which we have seen before. We've seen many cases throughout our history where people have experimented with languages, and then for whatever reason, that kind of opened up a Pandora's box, and suddenly everybody was doing their own language. But the other thing that we are seeing is we're exploring a lot of concepts within these languages because, quite frankly, a very important thing occurred a number of years ago, about 5, maybe 10 years ago. We discovered that the world did not stop with the invention of the object-oriented programming language. We discovered that God does not think in objects. Because what emerged, quite frankly, was this huge interest in functional programming languages, which solved a number of problems which object-oriented languages didn't, which of course leads all of the functional programmers in the room to nod and smile and say, yes, God thinks in functions. No, he really doesn't. He really doesn't. We stand on this threshold. Oh yeah, by the way, who's not interested in making money? Anybody in here who's complete socialist? No? Okay, cool. Because, I kind of like making money too. We stand on this threshold, and part of what's happening is we're actually closing a very, very important loop, which up until this point has been broken. See, historically, the programming language world has been broken down into two very distinct and very completely separate from one another camps. The first is the practitioners. I'm willing to bet most of the people in this room are a part of this camp. The practitioner camp is the camp of people who want to actually get shit done. If you are one of those, give me a hoorah. That was the lamest oorah I have ever heard. Have you never watched an American war film? Oorah! Come on now. Seriously, most of the time when you go to a conference like this, the people in the audience are people who are interested in getting stuff done. They are often working for somebody else, working on somebody else's problems, working to create software that will not be used by you, and you get paid to do that. And you get fired if you don't do that, right? I mean, you are building something typically for somebody else to consume, and you want to do a good job of it, don't get me wrong, and you want to make sure that the thing that you build is something that people will say, yeah, this is some pretty good stuff, right? You are interested in meeting deadlines, in accomplishing features. You are interested in making sure that what you deliver is in fact what was asked. You want to get this done quickly, correctly, and frankly, you just want to get it done. That's the practitioner camp. On the other side of that camp are the academics. Don Syme, are you in the room? Throw up your hand if you are. Don is actually an academic who is also a practitioner in the sense that Don currently works for Microsoft Research, steeps a lot of his life in the academic world, but he's also a practitioner in the sense that he is out there to create a programming language that people will genuinely use. That is to say, the F# programming language. He's like the only one. Most of the time, if you come to a conference, now be honest, and you see that a session is being given by Dr. So-and-so, PhD, computer science, MIT, how many of you actually want to go to that talk? How many of you believe that going to that talk will give you something that you can actually use in the office on Monday? It might be a brilliant talk. It might be an amazing talk. It might explode your mind and make you think about metadata in completely different ways. And then when you get back to the office and you say, and now I need to move this button 3 pixels to the left. Not sure how the academic relates to my life, which is very, very odd because in many other fields, in most other fields, to be an academic, to be somebody who is Dr. So-and-so, that is considered the pinnacle of success within that career. If we talk about medicine, the people who are in fact running the hospital were frequently the ones who were the best doctors. If we talk about lawyers, law firms, the people who run the law firms, they're the ones who generally had the most success in the court. The ones who didn't have success in court, we make them politicians. Or maybe that's just the US, I don't know. The academics are out there thinking about things. They are literally trying new stuff, new ideas, new concepts, new whatevers. And very bluntly, they don't generally worry about the things that we, the practitioner community, worry about. They're interested in exploring a new idea. We're interested in shipping stuff. Between these two groups lies a fairly sizable gap. And it does not help that in many cases, when we tried to use some of the academic stuff, the academics, when we would go to them and say, great, this programming language you've created is really, really interesting. How do I access a relational database? And the academic would say, who cares about relational databases? Just store it in a file. How hard is that? Right? Their view, their focus, their perspective is different from that of the practitioner community. If you say, how do I take your research language and run it in the cloud? They will say, why would you want to run it from 38,000 feet? That doesn't make any sense to me. You see that the academic community, their focus is on getting that new idea. They're exploring this new space. They're playing around with this new idea. And they don't know if this is going to work or not. They're much more interested in that feedback. Whereas we in the practitioner community, we can only use their stuff if in fact their stuff can do the various things we want it to do. It's not just about being a programming language. It's not just about exploring a new way of looking at the world. Compositional inheritance instead of traditional implementational inheritance. That's great. I love the idea, but how do I build a web server out of it? They're not interested in the things that we're interested in. And as a result, they don't spend as much time focusing on the details for the real world that we care about. And unfortunately, what that does is it breaks a feedback loop. And the feedback loop is the most important thing that we can have in computer science. If you look at, for example, the Agile Manifesto, if you look at all of the Agile practices that we see people doing today, easily 9 out of 10 are about feedback loop. Unit tests, making sure that if I change the code that I get feedback immediately to ensure that it didn't break. The on-site customer. If I build something, I want my customer to be able to look at it so that they can say, yes, this is what I wanted, or no, this is not. The whole notion of story cards, everything about the Agile Manifesto is about feedback. Because without feedback, we can't know if we're building something correctly or not. Regardless of how fast we delivered it, regardless of how spiffy and what features and how well it scales and so forth, if we don't get that feedback, we don't know if we're doing it at all well. It's no different in the academic world. And so historically, what has happened is the academics will go off and they'll do their thing, and the practitioners will go off and do their thing, and maybe 20 years later, what the academics were talking about makes its way around to what we deal with. This means that we don't get the benefit of the ideas that they're studying, and this means that they don't get the benefit of our feedback around their ideas. And that means that programming language research has generally been the province of the academics alone. And unless you're one of those who is so boring that you read academic papers on a Friday night instead of actually going out and drinking beer, you're not going to know about any of this stuff. You're not going to have the opportunity to take care of any of these things. And that's bad, quite frankly. I mean, if you want to really think about this for a second, the notion of object orientation took about 20 years for it to really sink into the mainstream. Smalltalk was one of the first, if not the original, object-oriented programming language. And really, it wasn't until 20 years after its original introduction that the notion of object orientation really started to sink into the mainstream. If you think about functional programming, some of the original report around Haskell and its predecessor Miranda, that was all done basically in the 80s. And there were some refinements that occurred after that. Dynamic languages, they were all the rage back in the 60s, Lisp in particular. And then over time, we got to a point where we said, maybe we could play around with this stuff. Ruby, JavaScript then came around the second time, because it was always there in the browser, but because it was called JavaScript, we thought it was supposed to be like the programming language Java, which was the worst naming convention ever, because that also suggests that ham should be similar to hamster. It takes a really long time for these ideas to eventually work their way out of the academic community and into the mainstream community. Until about, let's see, what year is this? 2019. Until about 15 years ago, there was a gentleman who had spent a bunch of time in the academic community and decided that he wanted to experiment with sort of this notion of how can we look at things beyond objects. And in particular, what he wanted to do is he wanted to examine a concept called meta-object programming, MOP. And meta-object programming is something that's actually very well known in the Lisp community. And he wanted to actually take that and bring it over into a mainstream environment, aka Java. And so he worked on a language that actually would let you do a constrained subset of meta-object programming. And he released this language, but contrary to what a lot of the academics had done in the past, he built this language deliberately on top of the Java virtual machine so it could in fact interoperate with everything in the Java community. He called his language Aspect J, and he called the style of programming that he created aspect-oriented programming. And if those of you have spent any time in the Java space, you know these terms because they actually became the hot thing to talk about in the mid-2000s. Because they captured this really nice middle ground between where objects left off and a lot of the distributed systems containers, EJB and so forth, wanted to pick up. And the main reason that this language got anywhere was because it was a language that was developed on top of the JVM, so it could be introduced directly into the mainstream right away. One of the tendencies we are seeing today, people are writing languages that transpile. That is an actual word. That means we go from source to source instead of source to binary, transpiling over into JavaScript. And the ultimate expression of that, of course, is Emscripten, which for those of you who haven't seen it, Emscripten is a compiler that will take C++ and compile it to JavaScript. Because reasons. As a matter of fact, the best demo of Emscripten that was out there for a long time, I assume it's still out there, somebody actually took the old Quake source code. You remember Quake? First-person shooter, run around bouncing all over the map, kind of like, Overwatch, but 20 years earlier. They took the Quake source code, they compiled it with Emscripten, and you can run it in a web browser. So again, if you're looking for things to do while you're waiting for Kevlin Henney's deadlock tests to eventually complete, time.eternity, you can actually go fire up a browser, fire up the Quake code, and when your boss says, "What the hell are you doing?" you say, "Language research. I'm doing a performance test to see how well natively compiled languages transform into the browser." At which point your boss will probably just say, "Okay," and wander back to his office, which is where he should have stayed in the first place, right? By the way, Emscripten is what later gave us WASM, which is WebAssembly, which is what will now run natively inside of most of the modern browsers. We'll talk a little bit more about that in a second. There's this interesting perfect storm. You guys remember that movie from about, I guess it was 10, 15 years ago? Right, George Clooney and I forget who else, they're on a fishing boat off of Boston. Several storms come together to form a perfect storm, right? The boat sinks, George Clooney dies, everybody's happy. Seriously, George Clooney dies. We're all happy about that, right? No? Maybe just me. All right, there's this perfect storm of things that are going on here. Step one, virtualization, right? We've seen some of that already. I'll talk a little bit more about what that means. We've got this plethora of language tools that are available to us. There's this notion that we actually do want to start thinking more about languages, which I'm just sort of categorizing as linguistic focus. And we had this hype curve that we've now sort of thankfully passed in the sense of domain-specific languages, the DSLs. We're past the point of DSLs being the most amazing thing ever, which means now we can actually figure out how to use them. As opposed to them being, now that everybody is so amped up around blockchain, we can actually start to think about how DSLs should be used. That creates this perfect storm center where we can actually do a whole bunch of interesting language research. Virtualization. Question. How many people in this room have had to worry within the last year about memory? Like you had to actually worry about deleting an object. Couple of hands, those are my C++ programmers, right? Or I'm sorry, Rust programmers, is that the thing du jour now, right? Because worrying about memory was so much fun back in the 90s that we have to bring that back. If you program in Java, if you program in .NET, C#, VB.NET, F#, etc., if you program in JavaScript, right? There is this underlying machine that takes care of all of these details. Did you have to worry about how to export your class name or function name so that it could be loaded dynamically at runtime? Did you have to worry about where your code would reside? Did you have to worry about how that code would be loaded? See, the virtual machine was invented literally to free you of all of these details. to not have to worry about whether or not this pointer that you just received in a method call is something that you own or somebody else owns, and are you responsible for deleting it? And if it's an array, do I have to use the special bracketed form of delete, or do I use the standard form of delete? What we discovered with the rise of Java is that love, true love, means never having to call delete. We just let the system worry about that. Now, there are still some edge cases we have to worry about. Database connections may not necessarily get released as early as we would like them to, so we have to put them in a special linguistic block so they get closed earlier than when the object would be reclaimed, blah, blah, blah. But for the most part, being able to ignore some of the physical details of memory management freed up a whole slew of brain cycles to focus on actual problems. Back in the day when I was doing C++, several groups did some interesting cognitive studies, sort of figuring out where you spend most of your time thinking when you're sitting down and writing code. And all of them came up to roughly the same conclusion. Half of your day programming, I should say, ignoring meetings and whatnot, was spent specifically thinking about memory management. Debugging problems when you got it wrong, debugging problems when you didn't get it exactly right. In other words, you forgot to delete something, so you had a memory leak that you had to close off. Half of your programming day, gone. All because you have to think about, when do I allocate memory, from where do I allocate it, how do I allocate it, when do I delete it, et cetera, et cetera. The main reason that Java took over the enterprise space in the mid to late 90s was not because Java was a superior object-oriented programming language. Quite frankly, Java, back in the day, is a crippled C++. It has nowhere near the number of features that the C++ language offers. The one thing the JVM has to its name basically is the fact that it managed memory for you. And a bunch of us C++ developers went, I like that, and I'm going to go do that, and that's going to make my life so much simpler. And it did. That virtualization takes care of a lot of those deep underlying details that, quite frankly, if you're going to create your own programming language, you're going to have to figure out, how exactly do I store code? Where do I store it? How does it get loaded? All of that is handled for you by a virtual machine. And so if I target my new language to an existing virtual machine, I get to reap the benefits of that VM. And when Oracle comes out with a new version of the VM with a new garbage collector, boom, my new custom language just gets better. But when I sit down to work on a programming language, like most developers, I want to have some good tools that are available to me in order to do that. I don't want to have to write everything by hand. The modern developer who wants to build a web application, when's the last time any of you built your own web server? Actually opening a socket and accepting requests over port 80, parsing out whether this was a get versus a head versus a post. Yeah, how many of you would even know how to begin building a web server? Okay, good, you're not all hopeless, that's good. Seriously, most of that is just stuff we take for granted. Here's a framework, they say. You just provide some entries in a construct that looks like this, and somehow magically, when somebody issues a web request against that server, boom, your code will be invoked. This is amazing. This is great. You could figure it out or build it yourself, but why would you? Having those tools, having those frameworks makes your life better. The language designers are in a similar spot. Up until about 15 years ago, the only tools they had were Lex and Yak. And I can tell who remembers those from college, because those are the ones that are currently curled into a fetal ball back there, shivering, right? Thought the therapy had helped them. Apparently it hasn't. We are so far beyond those two tools We have so many different tools, parser generators. One of the better ones that I like, quite frankly, is a tool called Antler. It's an open source parser generator. Can generate a variety of different kinds of parsers. It can give you the syntax, you can lay out, and it actually has a debugger to go with it. Because that's one of the hard problems when you're trying to build a language and you're trying to build out syntax, is trying to figure out whether or not there is an accidental infinite recursion somewhere inside your terminal productions and so forth. Debugging language syntax is actually a pain in the ass. And there have been a number of frameworks and tools that have emerged to actually make it easier to do things like back-end code generation. Now, again, if you're targeting the JVM, in many respects, you can just target the JVM. Here's a class file and off you go. If you're a .NET developer, you have Roslyn. Roslyn is literally a framework that the Microsoft language designers build to, so that you can leverage it to parse your code, you can leverage it to optimize your code, to do some of the various optimizations, AST passes, etc., that a modern language would do. Before Roslyn, there was actually the CCI, the compiler, or CCT, Compiler Construction Toolkit, which was sort of a predecessor to Roslyn. It's still available, it still works. Or there's Mono, Cecil, or there's a number of other .NET specific, assembly specific tools. These are all tools that make it easier for the prospective language designer to get going, get started. There are example grammars for almost all of these parser generators for just about any of your favorite languages. So if you really wanted to build a JavaScript that compiles to .NET code, to .NET bytecode, I mean, you actually wouldn't take you a whole lot of work to do that once you sort of reconciled JavaScript's weird sort of runtime object model to how this would work inside of the .NET world. The language designers need those tools every bit as much as you do, and they have a slew that are available to them that weren't there 2 decades ago. The other thing that we are seeing now is we're seeing emphasis on the idea of maybe there is a world beyond objects. The functional programming community did us all a huge favor. In many respects, Gregor Gonzalez started that when he introduced Aspect-J, and he started talking about aspect-oriented programming, and a lot of people started to understand what he was talking about. But we've also seen the functional community come around. We've also seen them talk about the benefits and the potential drawbacks of using pure functions versus impure monads and monoids and category theory and whatever. But one of the interesting things that Paul Graham, who has been a big Lisp file for many, many years, he will say that every so often, the language community discovers something that Lisp had from the beginning. They trot it out, they write it around, and everybody gets really excited. And meanwhile, the people who'd been using Lisp since the 70s just go, and? There's a bunch of things that have been introduced that Lisp didn't have. Paul Graham cites these 9 things. Some of these you will recognize. A notation for code using trees of symbols and constants. This is something we still don't have in modern programming languages directly, although you could argue that LINQ and some of its runtime expression generation is relatively close to this. But certainly when we start talking about functional languages, currying, pure functions, higher order functions have now made it in, partial application of functions, we still don't see that in a lot of mainstream languages. There's a lot of space in the functional world that people are exploring. If you were in Kevlin's talk just an hour or so ago, you saw him do an implementation of a stack that was purely done with recursion, using the stack as a stack. To a lot of people, that is a perfectly reasonable implementation, but would be very difficult to do in a language like Java or C# because the languages aren't really built around that. To do that in Haskell or to do that in ML, which is a purely functional language, much more approachable. We are talking about these ideas now. We weren't. When you go to a conference in 2002, we're not talking about language concepts. We're not talking about different ways to use recursion. We are talking about distributed systems, and that's it. servers and databases and application servers, and that is the principal focus of that particular decade. We are now at a point where people are starting to understand and talk more about these language concepts and being willing and interested in exploring more of these concepts. And that perspective is huge. Because there's a whole bunch of things that, quite frankly, we haven't solved. If you have been so fortunate or unfortunate, as the case may be, to work on a system that is a pure microservices-based architecture, and you are building a 12-factor application, and you're doing all of the things that that application asks you to do, in terms of the logging, in terms of the management, in terms of the backing services, and so forth, to go from zero to hello production, let me build a full-fledged, production-worthy microservice application, serverless or otherwise, that actually exports all of the necessary health checks, has all of the necessary administrative stuff, ties in with all of the necessary authorization and authentication tools. The cognitive load on the developer to deal with all of that stuff above and beyond the domain. Remember, this is hello world, but it's all the stuff necessary to go to production. Means that it's going to take you months to get a hello production microservices app out the door. That's too much. Hello world should be a couple of lines of code. And back in the 1990s, 1990, let's see, 94, I think it was, when we were building 16-bit Windows programs using the C programming language, hello world required 5 files, 4 pages of code, and a deep understanding of how messages get passed around inside of the Windows operating system. And then came C++. And C++ said, let's take an object-oriented viewpoint to this. Let's build a framework that will hide a lot of this common code. And suddenly, hello world went from 4 files and a 17-page switch statement down to 1 file, 5 lines of code, ship it. That's the kind of cognitive load that you have to deal with and have to find a way to get past. Because we've got, right, the whole concurrency thing, free lunch. Anybody know what I'm referring to there? Herb Sutter and his article, The End of the Free Lunch. I don't know if you guys have been paying attention to hardware recently, but, you know, Moore's Law states that every 18 months, the number of transistors that we can put into a single square inch of silicon doubles. And usually this translates to we double the amount of processor speed, we double the amount of memory, we double the amount of hard drive storage space, everything doubles about 18 months. And yet, the fastest CPUs we have are still measured in 4 gigahertz. And last year they were like 3.8 gigahertz, and the year before that they were 3.6, and the year before that they were like 3.2. Where exactly are all those transistors going? Well, Herb Sutter, back in, I think it was 2012, maybe, even earlier than that, maybe, Herb Sutter was noticing that we were seeing a plateau in these processor speeds, and he wrote this now very famous article called The End of the Free Lunch. The era of the free lunch is over. In which he said, basically, what's happening is we're not getting processors that are faster, we're getting processors with more cores. We have more CPUs available to us. When you buy a graphics card today, you are getting basically a card with like 1,000 GPUs on it, because we can pack all those transistors into creating all of these separately, independently, parallel processing graphics processing units. And it turns out that most graphics is very, very highly parallelizable. Embarrassingly parallel is the term that they like to use. So that means now as you start thinking about your code, you should be embracing the idea of doing things in parallel. And everybody in this room is completely comfortable with debugging highly multi-threaded programs, right? Show of hands if you are totally comfortable with debugging whatever parallel program. Come on, show of hands. Show of hands. No? Because let me be clear, guys, the processors are not getting any faster. So the era of your code runs too slow, you tell your boss that you need about 18 months for it to get about, twice as fast, and then you play Quake for 18 months and wait for the new generation of CPUs to come out and then tell them you need to do a hardware upgrade in order to take advantage of all the optimizations you put in the code, that's done. We don't get to do that anymore. If you are not taking advantage of the parallelism that is implicit in the CPUs that we are buying, your code's never going to get any faster. Do we have a programming language that deals well with concurrency? We have a number of languages that try to hide the concurrency. We have a number of languages that try to create constructs around the concurrency. We have a number of candidates who will tell you, oh yeah, we've solved the concurrency problem. And they've solved some part of it. And then we have promises. And I mean that both literally and figuratively. In the JavaScript community, the answer to concurrency is promises. Or we're going to actually have a multi-threaded JavaScript engine, which is really ironic because Node was trying to get away from multiple threads back in the earliest days of Node's release. Concurrency is still very much an unsolved problem. Security. How many people in here feel absolutely comfortable that your code is airtight from a security perspective? That there is no possible way that anybody who does not have the appropriate access token will ever be able to see something they should never see? Wow, you guys are really tired of raising your hands or something. Very bashful all of a sudden. There is a whole slew of these things that we need to solve. And quite frankly, coming up with yet another user interface framework for JavaScript for putting up buttons in a DOM and displaying it to people doesn't really address any of these issues. We really need to move beyond. And fortunately, there are a number of folks who are really trying to move beyond. Within the last year, I have become aware of 3 programming languages, the 3 listed up there at the very top, that are advertising themselves as service-oriented programming languages. As a matter of fact, Ballerina, which is the most fleshed out of the lot in terms of its documentation and so forth, Jolie is actually an academic effort. So it's been around a little bit longer, but it hasn't been used much. Ballerina is done by the WSO2 guys who have been big players in the web services space for many, many years. But Ballerina specifically does not have classes or objects. I mean, technically they have objects. They have instances of a map type, which behaves basically like a dictionary in just about any other language. They have instances of a JSON type. They have instances of a set, which is what will allow you to be able to consume stuff coming out of a relational database. But they don't have classes for arbitrary objects. Instead, you build services with endpoints. What would the language look like, the Ballerina creators asked, if you actually started with the idea of a service as a first-class concept, as opposed to something that you stitch a bunch of objects together to create? And that's a very reasonable question. There were a bunch of folks that started experimenting with, for example, aspect-oriented programming. Scala actually is a functional object hybrid that has also spent a fair amount of time exploring the idea of creating internal DSLs. Pizza was actually a very early language that ran on top of the JVM. It was actually a predecessor to Scala and the Java programming language. There is a language called E, because I think that was the only letter left. But E is actually exploring the notion of capabilities-based security. What should various objects be allowed to do? What should their capabilities be when you are talking about this particular language, and how will it work and so forth? In the Microsoft space, of course, you've got Link, you've got F#. There are a number of languages that have emerged out of the academic community, including Nemerly or Nemerl, depending on who you ask. Boo was a language that was created by Allende back before he got RavenDB off the ground. And Boo was a language which allowed you specifically to play around with the AST at runtime. Very Python-inspired syntax. But the idea is that you could actually create constructs and then during the compilation phase, get hooked into the compiler and be given an opportunity to modify the code before it was finished compilation and emitted. It's a tremendous amount of interesting ideas. And then outside of the two virtual machine spaces, Haskell, Erlang, which now, by the way, has given us Elixir, as well as a couple of other things. Haskell begat Elm, which is a Haskell running inside of the browser, and Elmish. I think Elm has been renamed to Elmish and so forth. There are so many of these different languages running around. And if you really want to start playing around with some of the originals, you really want to explore some ideas that you haven't really seen before, fire up a Smalltalk browser. Dolphin Smalltalk or Pharaoh or Squeak, any of those guys, because one of the interesting things that Smalltalk has been living this virtual machine lifestyle for the better part of half a century. And they have discovered some things you can do with a virtual machine that those of us in the Java and .NET world hadn't even begun to consider. For example, about, it would be almost 20 years ago, I was working for the University of California at Davis, and their registration point of sale system, literally the application that ran in the registrar's office when students would come in to pay their reg fees, it was written in Smalltalk. And there was one guy, Larry was his name. There was one guy who had been working on this point of sale system since forever. I mean, he was your classic bald with white hair around the edges, little scatterbrained sometimes. Larry was never going to be fired, and he was very happy about that because they let him play in Smalltalk. It was a very sort of symbiotic relationship. But one day, the registrar's office called over and said, hey, there was a problem. Larry said, I'll be right there. And he promptly hung up, and he got up, and he put his jacket on. I'm like, Larry, what are you doing? He's like, oh, I have to go over to the registrar's office. They had a problem with the point of sale system. I'm like, oh, yeah, Smalltalk. It sucks, whatever. Go back to my Java. Larry comes back, and what he's got basically is a floppy disk. Either a floppy or a USB key. I can't even remember now where we were in the cycle. But he's basically got portable media with him. And I'm like, what's that? Is that like a dump of the log file? He's like, no. This is the crashed program. I'm sorry, Larry, what? This is the crashed program. Here, let me show you. He slides this thing into his machine. He brings it up. What I discover in that day is that Smalltalk is not just a language, it's the browser, it's the environment. The browser and the environment are the IDE. And so when you're running this Smalltalk application in the browser, not the web browser, but in the Smalltalk browser, when an exception occurs, the user has the opportunity to hibernate, literally take the entire Smalltalk browser program and serialize it to disk, error state and all. Copy that file off to a portable media, bring it back to his desk, bring it up, and he is not looking at log files. He is not attempting to piece together a stack trace. He is looking at the actual running program at the time the error occurred. Okay, that's just fucking cool. And neither the JVM nor the CLR have even begun to embrace that, although they very well could. There are still lessons to be learned from the languages of our ancestors, and it's worthwhile to study them. The other thing I will point out is even if you have never built a programming language anywhere in your history, if you were not a computer science student, which I was not, my degree is actually in international relations. If you really want to have fun, buy me a beer, actually a glass of wine, and ask me why war? Because that was my final for one of my classes in university. I didn't study computer science. I studied international relations, foreign languages, et cetera, et cetera. And I have successfully created programming languages. Once you understand some basic concepts about parsing the abstract syntax tree, transformation into either an interpreted model or into bytecode for execution, again, there are frameworks and tools to help you with this, and you can start relatively small and build your own language in a day. And let me be very clear. There is no thing that a programmer can do that will gather more respect from their colleagues than create a programming language. If you say that you are working on your own language and you show them actual code in your language that you can compile and run, they are obligated to let you have the first slice of pizza. Because it means you understand a subject that most people consider to be deeply arcane and mysterious. And the doors are closed. We'll let this be our little secret. They're not actually that hard. It's really not that complicated. You can make it really complicated. You can make it really super complicated, Scala. But it doesn't have to be. How real are these? I mean, to be fair, right? Ted, you're up there on the stage. They asked you to do a keynote. You're supposed to sound inspiring. I'm getting kind of jazzed up, but I can just see me going back to the office and starting to work on this. And all of a sudden I lose all that momentum because I realize that, yeah, who's going to really use this? And to be fair, right? To be fair, other people creating languages generally don't have a phenomenal amount of success. For example, if you are a professor at a university and you create a language, the number of people using your language directly correlates to the number of undergrads in your class that you can force to use your language. Okay? And maybe the TA. And if it's a successful research language, it means that you've convinced a couple of other professors to do some research on your language, and they make all of their undergrads use the language. But eventually you move on to something else, they move on to something else, and the language dies. And this is the fate of most programming languages in the academic community. If you're really lucky, your language will be used for 10 years within the academic space, and then it just dies. Now, of course, thanks to GitHub, programming languages never actually die. They just live forever in kind of a frozen state. Kind of like Captain America. However, some languages will cross this threshold of immortality and will never die. Even though they should. I'm looking at you, Perl. I mean, seriously, the Perl community has done everything they could to try to kill it off, and still it lingers. Okay, but all of that aside, almost all of the languages that we currently use started life in research or academia. C++ began life at Bell Labs when Bjarne Stroustrup decided he wanted to create a language that was designed to pull some ideas out of Simula and Self and a couple of other places to create a object-oriented language, a system-level object-oriented language. That was done at Bell Labs. Many of the languages that we use today, as a matter of fact, were originally inspired by some of the work done at Bell Labs. Smalltalk itself was done at the Xerox Palo Alto Research Center, Xerox PARC. Pascal, C, all of these languages began life either in a research institution or in academia. The only languages of note that were actually created by the industry, Ada and COBOL. How many of you want to volunteer for either of those languages? Yeah. So just because, people have created some of these languages doesn't necessarily mean that they're any better or worse. In some cases, the right language just has to be available at the right time. Remember, JavaScript was actually created in 1992? No, a little bit later than that. Basically around the same time that the browser was first starting to gain some traction. And it's not until the last, say, 5 or 6 years that JavaScript has really taken off as a programming language. Prior to this, JavaScript was just something you view, source, and stole from somebody else's web page, pasted it onto your web page, and when it didn't work, you said, stupid language, and gave up, right? But there's some interesting ideas that were floating around out there. So this, for example, this is a flavor of JavaScript that has since been basically thrown away. It was called E for X, E standing for ECMAScript, because that is the actual official name of what we all call JavaScript. The idea was that we were going to integrate XML directly into the language so that here, var order was going to be a reference to an object that was strictly hierarchical that started with an order node, which had a child customer node and a child item node, and we could reference them by name like so. This was suggested back when we were really thinking about web services being XML-based as opposed to JSON-based, which is so much better. And I say that with a high degree of sarcasm. But just the idea of let's integrate XML directly into the language is not actually a terrible one to start with. What are some of the things that we can get out of it when we have a strictly hierarchical representation, particularly because we can incorporate XPath, which was a query language for XML, directly into the language at that point, which is what E for X ended up doing. Or let's take a completely different view. This inside the box is a programming language called Inform 7. Yes, ladies and gentlemen, that is a programming language. That is a programming language for creating interactive fiction. Basically, if you ever played adventure games as a kid, you were playing interactive fiction. That's just cool. I mean, you look at that and say to yourself, could I present this to the business analysts, to my power users, to the people who understand it? Could I give them something like this and let them write the code directly? That's a pretty reasonable case you could make there. Now, in some cases, we don't want to go quite so far with quite such a strong English bent. We just want to incorporate certain kinds of language concepts. So here what we see is an internal DSL from Scala. In other words, this is actual Scala code here. Anybody want to take a gander as to what this actually does? And if you say, it looks like it's querying from a relational database, you're right. This is a DSL for doing database query. So let's assume for the moment that you're convinced. Let's assume that you're like, okay, I got it, I get it, I'm fired up, I want to start using some of these languages, I want to start playing around with some of these languages. I just have a big problem. How do I convince my management that this is actually a direction to go? Because let's be clear, management actually has a legitimate concern that if we start playing around with some goofball academic language that is going to die that quick death that we showed earlier, then where are we going to find people who are going to support it and so forth and so on? And you found a language that isn't an academic language, that actually is available on GitHub, is actually something that you would be willing to support going forward, etc. You've got all the technical concerns handled, but your boss still isn't convinced. How exactly do we do this? Basically, two paths, right? Number one, assuming your boss is like much management, he's strongly opinionated about software and knows nothing about it. Assuming your boss is like that, it's likely that the third path, which is I'm going to sit down, have a reasonable conversation, and my boss is going to say, you know what, this bears examination. Let's try a small prototype and see where we get. If you have one of those bosses, that's amazing. And you are to be congratulated for having found a good place to work. And please tell me the name. Nobody wants to shout it out. All right, fair enough. Assuming you don't have one of those bosses, then you have two paths available to you. Number one, right, just overwhelm them with technical stuff, convince the boss this is the way we go, and start slowly. Or number two, what your boss doesn't know can't hurt them. And when your boss comes to you and says, hey, Ted, why is it that so many of our C# files have a .fs extension? And you say, oh, that's just the next generation of C#. They didn't want to confuse the extensions, so they gave it a separate one. It's okay, go back to your office, we got this. Right? Because, you know, what goes in Vegas, what happens on the road. Look, I can see that we have this transition coming. The cognitive load on the average developer to build services, to build microservices right now is way too high. Hundreds, if not thousands of lines of code to get one concept across in a microservice-driven application because of all of these other concerns. This is the same place conceptually that we were at when we were working with native languages, C and C++, and then we made this transition to the virtual machine, which took so much of that load off, and we suddenly had this explosion. This was literally when the whole open source movement really got ramped up and started. There is a tremendous amount of brain power that if we can free from doing all of these low-level plumbing tasks and make the plumbing live inside the walls where we don't have to see it except when we want to go tinker with it, then we can start being super productive again, as opposed to spending months building a service that really, in the grand scheme of things, doesn't seem to accomplish all that much. There are so many areas that we can explore. Again, if you were in Kevlin's talk in here a few minutes ago, you saw him drawing out a state chart for the stack and showing some of the interesting insights. Why have we not incorporated the notion of state transition and state transition syntax directly into a programming language? Instead, we leave it up to you, the developer, to manage all of that stuff by hand. There's a pattern. The Gang of Four described, here's what the state pattern would look like, but nobody has actually tried to incorporate that directly into syntax. There are so many areas of exploration and research that we can dive into that for particular industries that you might be involved in, certain areas will be far more interesting than others. Don't wait for Don Syme and Anders Hallsberg and Brian Getz and all of the other language design. Don't wait for them to solve the problems, because they will solve the problems for everybody, which means in many respects they're not solving anybody's problems. Your company, your line of business, your industry has specific problems that are unique to your space. Start thinking about how would you solve them differently if you had the syntax to support it. Experiment with some syntax and build it. Any questions? Peace.